Hey y'all. So today's lesson is inverse variation. You maybe remembered direct variation last year, y equals kx. So this is an inverse function, and it's y equals k over x, where k cannot be 0. It's the constant of variation. And x cannot be 0. The reason x cannot be 0 is because it's in the denominator and we cannot divide by 0. And just a little bit about this function. The domain, the x values are all reals except x cannot equal 0. We already talked about that. Since k cannot equal 0 and x cannot equal 0, that means that the range y is all real numbers except for 0. If k and x are not going to be 0, then there's no way for y to be 0. And there are vertical and horizontal asymptotes because x and y cannot equal 0. The asymptotes are where x equals 0 and y equals 0, which are the axes. So in just the parent function, y equals k over x. Like here is y equals 1 over x. The axes are your asymptotes. So the function, it's got branches. This little piece is a branch and this piece is a branch. They are not going to cross the axes or the asymptotes, wherever the asymptotes may be. If k is greater than 0, so this value right here, k, so in this case, k is 1. If k is greater than 0, then the graph is going to be in quadrant 1 and quadrant 4. If k is less than 0, so let's say this is a negative, then the graph is going to be in quadrant 2, sorry, I messed up, quadrant 1 and quadrant 3. If k is less than 0, so if k is negative, then it's going to be in quadrant 2 and quadrant 4. So my apologies. If it's greater than 0, like in this instance k is 1, it's going to be in quadrant 1 and quadrant 3. So that means all the values are positive or all the values are negative. If it's a negative k, then it's going to be in 2 and 4. And so that's what this says right here. Okay? And we're going to talk about translating this inverse variation function. So if you have the parent function y equals k over x, to translate it, that means we're going to have a horizontal We're going to have a horizontal translation and a vertical translation. So the vertical is going to be this plus c. Plus means up, minus means down. We got that. This horizontal is going to be that reverse like we're used to. So if it actually says minus b, that means we're going to be shifting right. And if it says plus, that means we're going to be shifting left. So you have to remember this value right here, normally it's the inside. So in this one, it's in the denominator. It's going to be that reverse, that opposite. So let's talk about our asymptotes. We have a vertical asymptote where x equals b. So let's say this was x minus 2. So that means that x equals 2 is going to be an asymptote. And that's where the denominator is going to be 0. Where this whole thing is going to equal 0, you remember we can't have it equal 0, so that's where the asymptote is going to be. The horizontal asymptote is wherever c is, where y equals c. Because then y can't equal 0. So let's just pretend, I don't know, c is plus 4. Well, that means at 4 there's going to be an asymptote because we can't have, can't touch that value. And then k tells us the distance the branches are from the asymptotes. So in the graph that you just saw, those little curved lines are touching the asymptotes. And k is going to tell us about how far those are away. And the way we find that is we take the square root of k. So if k is 4, then the square root of 4 is 2. So the branches are going to be about 2 blocks away, or 2 little grid units on the grid away from the asymptotes. Alright, so we're going to put all of this together and we're going to find domain and range, the asymptotes, we're going to find the quadrants, and we're going to find the distance. And we're going to sketch the graph of an inverse function. Alright, get this down. Describe the translation, and then we're going to sketch the graph. So I've done this one completely for you. I'm just going to go through it with you and talk about it. Here's the function, y equals 1 over x minus 3 plus 4. The 1 is your k, and then we have a horizontal translation and a vertical translation. So because it says -3, really it means we're shifting 3 to the right. And you can see on our graph, 1, 2, 3 over to the right, even though it says -3. This 4 means up 4, and you can see 1, 2, 3, 4. We have shifted what used to be the origin, the axes and the origin, has been shifted. So the domain of our function is all reals except 3. We cannot have a 3 right here, because if you were to put a 3 in here, 3 minus 3 is 0, and remember we can't have a 0 in the denominator. So the domain is all reals except for 3, and notice that's why we have an asymptote at x equals 3. So wherever the domain is, the vertical asymptote is x equals 3. It might sound a little reversed, but this means we can't have an x value of 3. Notice, over 3. Up 1 over 3. Up 2 over 3. We can never have an x value at 3. And that's what makes a vertical asymptote, is when the x is equal to 3. The range values are all real except for 4. So notice, all real except for when y is 4. Y cannot be 4. That is where our horizontal asymptote comes into play, where y equals 4. Wherever the range is, it's going to be the horizontal asymptote. It kind of sounds backwards, but that means the y values cannot be 4. If, the k right here is positive, so that means it tells us our graph is going to be in quadrant 1 and quadrant 3. So I've shown you in quadrant 1 and quadrant 3. Remember, it's shifted, but we know that it's going to be in quadrant 1 and quadrant 3. And then the distance from our branches. Since k is 1, we take the square root of k. So the square root of 1 is 1. And you can kind of see this dot right here. From our asymptote, I went over 1, up 1, and then that's where I put my dot. So that kind of gives us the distance away. That's going to be the greatest distance away from our asymptote, and then it's a curved line. So I know this was quick, but hopefully you're seeing the connection between the domain and the range, and the vertical asymptote and the horizontal asymptote. Alright, now this one I've done partially for you, so I'm going to work through it a little bit. Oh yeah, and I brought my calculator because we can check, so I'll check after this one. Y equals -4 over x plus 1. So again, we're just looking at this plus 1 is really going to mean we're shifting left 1. So that means this x cannot be a -1, because if this x is a -1, that means this value would be 0. We can't have a 0 in the denominator. So look over here, my domain is everything except for when x is -1. I don't have any plus anything out here. I don't have a +4 or -4 or anything. So that means my range is all reals except for y equals 0. So my original range is going to come into play because I haven't translated it vertically any. Because my domain is x is all reals except for x when x is equal to -1, that becomes my asymptote for x is -1. So if I go in, I'm going to put an asymptote where x is -1. That means all of the values when x is -1. Because I don't have anything out here and my range is all reals except for y equals 0, that means my asymptote is going to be here where y equals 0, and that is the x-axis. The x-axis is where y's are zeros, because you know it doesn't go up or it doesn't go down. So I have my asymptote. Now I want to know my quadrants. So quadrants. Because k is negative, you see that negative right there. That means we're going to be in quadrant 2 and quadrant 4. I've already written it. Quadrant 2 and quadrant 4. So we're going to be over here, and we're going to be over here. And then the distance away from the asymptote, my distance. So k is 4. We're just going to use the positive. Take the square root, which is 2. That means my asymptotes are going to be about 2 blocks away. And we're just going to sketch. So if I'm going to go this side first, here is my asymptote. So I'm going to go about 2 blocks, over 2, up 2. And I put my dot, and I know that it's going to be curved. And then over here, 2, 2, and it's going to be curved. So you can see that our equation, our graph, is pretty far away. So I'm going to type this into my graphing calculator. -4 divided by x plus 1. And when I graph it, I see, it's hard for you to see, but maybe you can see that, I don't know. I see a vertical asymptote at -1. It doesn't necessarily have a line. Well, I mean, it's the x-axis. So you see it doesn't cross over the x-axis, and then it's a pretty good distance away from the asymptote and the branches. So that is how you would sketch a graph of an inverse variation function. All right, example 3. This one we're going to do together. Y equals -1 over x plus 4 plus 5. So I think in general, generally, let's just look at the bottom, the domain, x plus 4. The domain is going to be all reals, except x cannot equal -4. So remember, it's the opposite. This means we've shifted 4 to the left. And if I'm taking this point and I'm shifting 4 to the left, that means it can't equal -4, so my vertical asymptote is x equals -4. All right, now let's look at the range. The range is going to be all reals, except y can't equal 5. So what it means is we've taken the parent function and we've shifted it 5 units up. And because of that, I means I'm going to have my horizontal asymptote at y equals 5. Oh, right there. Okay. My quadrants, because my k is -1, that is less than 0. That means I'm going to be in quadrant 2 and quadrant 4. So I'm going to be over here and right here. And the distance, my k is 1, so the square root of 1 is 1. So my distance is only going to be about 1 block away, and so it's going to be rather close. So in this, when I sketch this graph, I know I'm going to be in quadrant 2 and quadrant 4, and I have a distance of 1, so that means I would go 1 and 1. And here is my inverse function sketch. And if I wanted to, I would go to my y equals, and I would type in -1 divided by x plus 4 plus 5. And then when I graphed it, I would see the asymptote at -4, and then I would see that it shifted up 5 units, and I can see that right there as well. Alright, so the last examples are when you have been given the parent function and the asymptotes and asked to write an equation. So this part is really easy going backwards. For the first one, y equals 9 over x, that's our parent function, and they've given us an asymptote at x equals 2 and y equals -2. Then you just plug it in. Now remember, the vertical asymptote at x equals 2, when you put that into your equation, it's actually going to look backwards. That one's going to look negative. So you start with 9 over, and then where x is 2, that means it's going to be -2, because remember, it's going to be backwards. And then the horizontal asymptote where y equals -2 is just going to be a minus, because that means it's going to go down 2. So this part is really easy. Number 5, parent function of y equals 4 over x, and your asymptotes are x equals -3 and y equals 0. We're going to start with y equals 4 over. Now, if you have this -3, when you put it into the equation, it's going to look like x plus 3. Because remember, if you have gone 3 units, like this means -3, so 3 units to the left. And in order for it to be 3 units to the left, the equation is going to have to say plus 3. And then y equals 0, well, we don't need to write plus 0, so we're done. This is it. This is going to have a vertical asymptote at x equals -3, and it's going to have an horizontal asymptote at y equals 0. All right? So that was a lot about inverse variation, and we will practice more.